Hello, everybody, and welcome to this session. So my name is Steve, and I'm going to be talking to you today about how you can use .NET Aspire along with some other .NET technologies like semantic kernel to add some AI-powered features to your business applications. So I hope that's going to be useful and interesting to you, and we'll cover a few new areas that you don't know about. Now, we won't be able to go through like every line of code needed to do this, but my goal is to give you a general sense of inspiration about what you can do and an awareness of what technologies you can use and roughly how things will fit together. Okay, so let's start by thinking, what does it actually mean to add some AI to a business application? And I know you're probably thinking at this stage, oh, he's going to tell us to just add some chatbots to stuff, right? That's all we do these days. We just add chatbots to everything. But no, that's not the point that I'm going to try and make. And in fact, I'm almost kind of making an opposite point here, which is I think when you start with this sort of area, you should start by thinking really quite broadly. There are many other ways to add AI to your application. What about, for example, taking your search features and upgrading them to be semantic search, so people can find things that are related to concepts without having to spell them exactly right? What about summarization, so people don't have to read long blocks of text and they can pick out the relevant bits very quickly? Or type ahead, so people don't have to type everything character by character and the system can prompt based on what's going on? Or have intelligent workflows with automatic categorization. So there are many, many different ways you can add AI features to your application. And you need to be thinking about, what are my users really going to use? What they will use is stuff that actually saves them time and effort. There's no point in spending months building something that people don't even use. And finally, I want to encourage you to think about ways that you can make stuff measurable, so that you can work out formally, is this actually helping? How good is the quality of this system? What does it cost? How fast is it? That sort of thing. And we're going to talk about that later in this talk. So let's start going through a sample application. And I'm going to try and make this as relatable as possible. So we're going to use the most predictable standard business scenario that we can possibly imagine, which is some sort of e-commerce application. So you could imagine that there's some sort of e-commerce site called something like eShop, maybe. You might know that we actually do have a sample e-commerce app called eShop. But in this case, it's not just about buying products, it's about customer support. So imagine that there's also a way that customers can go and submit support inquiries to say things like, oh, I've got a technical question about this product, or I need to return a product, something like that. And they could submit those inquiries through a web UI, and they're going to go to some staff working for the company who will handle those inquiries. So maybe there's some sort of UI that staff work with that looks like this, where they can see what tickets are open and search for them. And then probably there's going to be some sort of big grid that they can see the backlog of work. So a very standard business scenario. Can we actually benefit from AI in a case like this? Well, I think we can in many ways, actually. So we've got a search feature, so we should immediately be thinking, well, is this going to be more usable if it was semantic search rather than just exact text search? We've also got titles here, and that's an example of summarization, because who do you think is going to write these titles anyway? Well, customers are not going to write them, and we don't want to make our staff spend their time writing little titles. So we can have an AI system automatically generate helpful little reminders of what each support ticket is about, so people can navigate more fast through that UI. We've also got a scenario where we might want to automatically classify things to trigger different workflows based on what the customer inquiry seems to be about. And then finally, we've got these satisfaction scores over there, and it's very easy to use a language model to assess sentiment of things that people are writing. So we can use that to direct the staff to focus their attention on things that are the most urgent. All right, but that's not all. We could go a bit further and we could say, what happens when the user clicks on one of these things to start working on a support ticket? What will they see? Well, they've probably got some fields that they can start filling out to edit, to edit this support ticket. And once again, we can use typical AI services like classification and semantic search to help people move a bit faster through this application. Then maybe there's a big conversation where the staff member can talk to the customer, and it could be a really long conversation, and we don't want the staff to have to spend hours just reading through all these chat backlogs every time they open a support ticket. So wouldn't it be nice to use some automatic summarization in there to direct people to the current pressing issues? And then when the staff member wants to actually answer these questions, well, at that point, it probably is useful to have some sort of support chatbot system that's able to find relevant answers, for example, searching through product manuals in this case. But of course, we really need it to be accurate, and we want to avoid the risk of hallucination. So we're going to need to make it generate citations so that the staff member can verify that the claims it makes are actually true. And then finally, when they come to actually type out their responses, it would be nice to save them the trouble of typing everything character by character, and we could automatically type ahead and suggest content based on information that's available. So lots of ways in which AI could be useful in this very typical business application. So let's start looking at some code now and see how you can do that with Aspire and Semantic Kernel and other technologies. So I'm going to start with this application. Okay, so I've got my solution here in Visual Studio. I've also got it running here in a browser, and you can see it's running inside Aspire in a similar way that Glenn and Maddie were just showing. So I've got all these different services that are linked together by Aspire. I won't go through all of them, but relevant ones are the backend, which is a web API service where all my business logic is. And I've got a couple of different web UIs, one for customers, one for staff. And we'll start by going into the staff one. All right, so you can see initially it looks a bit like what I had in those PowerPoint slides, except we're missing a bit of information, like we don't have summaries, we don't have satisfaction scores. And if I go into one of these, you can see, okay, we've got this really long conversation, so long that there's no way that I can possibly bother to read it. And I really want some sort of automatic summary to appear. So let's start by adding that feature to our system. And the way that we'll make it work is every time someone sends a message, whether it's staff or customer, every time a message is added, we'll regenerate a summary of the support ticket up to that point. So if I send this message right now, I want a summary to be generated at that point. So let's go into the code here, and I'm going to go into the backend API here, and you'll see I've got this ticket messaging API, which uses ASP.NET Core to set up these endpoints that receive requests to add messages, and then they're going to call this method post-message async, and that will use some standard entity framework code to add a message to our database. But what I want to add is generating a summary. So I've added a reference to this ticket summarizer class, which I've implemented, and that takes in the AppDB context so that we can work with the database. And more interestingly, it takes an iChat completion service. Now, that is an interface provided by Semantic Kernel. Semantic Kernel is a set of .NET packages from Microsoft that give you the ability to work with various types of AI services. And Chat Completion Service is the one for language models or chat systems, which is the most common kind of thing that you will want to do. And when we want to use that, we can set up a prompt that we'll pass in. So we'll say you're part of a customer support system. Here's some details of a support ticket. Here's all of the contents of the message log that we're injecting into the prompt. And we tell it what to do. We say, okay, generate as a summary that's up to 30 words long. Also generate a shorter summary that we can use on the ticket list page. We'll also ask you to generate a customer satisfaction score, giving one of the various labels that have been set up to represent customer satisfaction. And we'll ask it to return some JSON that we can use in our system. So we'll use the iChat Completion Service API to say, give us a response to that prompt, and then we will parse it as JSON, and we can use that to display stuff in our application. So now I've added that to my system, I'm just going to restart it, and we'll see, hopefully, that when I add a message to the chat log just there with the customer, it will generate a summary automatically. So here it comes back up, and I'm going to go back into my browser and just wait for that to restart, which it will do very soon. It always takes a bit longer when you're doing a presentation. I think it's the time spent encoding this video. It's normally instant, but here it comes, I'm sure. Right, here we go. All right, so we're back in. So now this time when I send a message, at this point, it's going to run the code that we just implemented and generate a little summary. And you might be wondering, well, how is it generating that summary? Are you using OpenAI or some other kind of AI service? Like all we saw so far was iChat Completion Service. And why is it taking so long anyway? Well, the answer to that is because actually what I'm using here by default is Ollama, which runs locally on my development laptop. So it's not using any external service at all. Ollama is a way of running large language models just on your own machine. And I'm using Mistral 0.3 as it happens right now. So that's why it took a little moment to start up. And if you're wondering how all of this is controlled, well, this is controlled in the Aspire layer. So semantic kernel is great in that it gives us these abstractions over different AI services, and then we can swap out different implementations behind the scenes. So in this case, you can see I'm using Ollama by default, but if I want to, I can comment that out and replace that with a connection string. And in this case, I've got the connection string configured to use Azure OpenAI on the back end, but I could also point it to other things if I want to. So just by changing that one bit of code in app host, I can reference different AI services, and I don't have to change any other part of my application. So when this comes back up just now, let's restart that. And then this time, if I send a message, let's go into a different one. Let's go into here, and I'll say, what is wrong to this customer? And when we send that, this time it doesn't have to start up Ollama. It's just going to go to an external AI service and generate a nice little summary. Also, if we go back to this list, you can see it's generating short summaries and it's generating satisfaction scores, just like we asked it to. All right, so that's semantic kernel and Aspire working together. And they're doing a little bit more stuff behind the scenes as well to help us out. For example, if I go into this tracers view here, we can see everything that's been going on behind the scenes. And if I look at the context of this particular staff member and we see all the different API calls that they've done, then if we look closely, then hopefully we will see somewhere in this list. Oh, we won't because I've just lost my connection. So let's just restart that. Go into tracers and have a look in here. Then we should see somewhere in there a call to a language model. So you can see that semantic kernel knows how to integrate into Aspire tracing, and it shows us our calls to chat completion. We can see it was using GPT-3.5 in this particular case, and we can get all kinds of other bits of information like how many tokens were used, which determines the cost of it, how much time it took. We can see the entire prompt that was passed in, and down at the bottom, we can see the entire response that comes back. So if you're doing this in production, you'll get all these statistics and you can keep track of all the tokens that are being used and what the costs and timings and so on are. Okay, so that is getting started with doing a little bit of summarization. Okay, now let's move ahead and add some more interesting features to our application. Let's now move into the most sophisticated part, which is in fact an AI chatbot, which is going to answer customer support inquiries for our staff to help them do their job a little bit faster. So I'm going to go into another ticket now, and you'll see I've got a bit of a problem, which is this customer is trying to talk to me in German, and unfortunately I do not speak German. So maybe I would hope that I could come over here and try and ask something like, what are they asking? Translate into English. Okay, and it would be nice if it could answer a question like that, but it cannot yet because I haven't provided it with any information. You can see it's giving me this useless generic response saying, what do you want me to translate? So why is that? Let's look at some code. It's because I've deliberately failed to give it any context just so that I can show you adding it and you'll get a sense of what it's like to build this sort of thing. So here's the API that gets called when I send a message to it. And you can see that just like before, we're using an iChat completion service that gets supplied by semantic kernel. And once again, we're setting up a prompt saying, you're a helpful AI assistant and giving it some other instructions, but I haven't actually told it anything about what this support ticket is. So of course it can't really answer questions about it. So all we have to do is give it some extra context. So I've added this extra block of code here, which is giving it the product ID, product name, the summary that we generated, and the most recent message that was supplied by the customer. And so now it does have a bunch of extra context, and hopefully it's going to be able to give us a slightly more useful response. Let's see how it behaves now if I ask it the same thing that I did before. Okay, so that's going to restart and reconnect. And I'm going to ask it exactly what I asked before, which is to translate this customer support request. Okay, and now we'll see it does actually have the context and it gives us a nice clean translation into English for that. So that's good. What they're asking for is how to pair it with their phone and what is the Bluetooth pairing pin. All right, so let's imagine that we're the staff member and we want to actually answer that question. Now, what is the Bluetooth pin? I don't know. We're going to need to go and have a look at the product manuals, but I don't want to do that myself. I would like the AI assistant to do that for me. So maybe I could ask it something like, what does the manual say about this? And unfortunately, it can't yet do that because I haven't yet given it the ability to search product manuals. So it says, I will look up the manual, but it's completely lying. It will not look it up because it doesn't actually have the power to do that just yet. So let's go into our code and see how we can give it that ability. So where this works with semantic kernel is that you have this thing called a kernel. And this is where you can register all the different facilities that's available in your AI system. And one of the things you can register are callback functions. And this allows you to implement a pattern called retrieval-augmented generation, or RAG. What that means is that during generation of a response, we retrieve some data, and then that can be used to produce the response. And the way that we retrieve data is with a callback function. Okay, so I'm going to register a callback function with semantic kernel, and I've already implemented that function down here. I've got this class called search manual plugin with a function that's decorated as a kernel function to make it available. And it takes a couple of parameters. It takes a search phrase and it takes a product ID. So we know what product we're searching for. And the main important thing that we're doing is we're doing a search against the product manual. And you could implement that any way you want. You could use a traditional database full text search system, or you can use a vector database and semantic search, which is what I actually am doing here. I'm not going to talk about how that works on the inside. You can hopefully look at code and see examples of how to do that later. But the important bit is that after we've done that search, we return it back to the language model, and it will use that result to supply a response. And all this other stuff we're doing here is just to update the UI, to say that we're searching, and to display citations in the UI. Okay, so now I've done that. Well, I actually haven't changed my code yet, have I? So what I need to do is plug that into the kernel. So I'm going to go over here and say import plugin from object and give it a reference to the search manual function that I just had right there. Okay, so let's bring that back up and we'll see when that comes back. We'll reload. And this time we should be able to ask it questions and it will go and look in the product manual and get actual practical useful information. So once again, I'm going to say, what does the manual say about this? And it goes and it searches in the manual. It's picked its search word of pin code pairing, and I've done something to break it. So let's try that one more time. Okay, so it's given us a nice response here, including the pin number 0000. And if we want to check that that's actually right, we can click on this citation link and it takes us into the actual product manual PDF and highlights the text so that we know that it's actually correct. So now we could say something like, write a reply saying that, and it will hopefully produce a reply to the customer. So that's pretty good. And in fact, I'm going to say no in German to the customer. Okay, because this customer speaks German, and it now produces a nice reply to this customer with the pin number in it, and it produces this button, users reply, so I can just fill out my name and get rid of this bug at the bottom there and hit send, and it's going to send that reply to the customer. All right, so you might be wondering, why does this button users reply appear sometimes, but not always? Well, that takes us on to this next thing, classification, which is a general technique you can use in your application to trigger different behaviors based on what's going on in your application. And in this case, I did it in a very simple way using a language model. So what I did is in my code, after we finished streaming the response to the UI, I was sending a further message to the language model saying, hey, consider that answer you just gave us, decide whether it's suitable to send to the customer, like is it addressed to the customer, and give us a Boolean, true or false, about that. And then we parse that JSON response, and based on whether or not it is suitable for sending to the customer, we trigger a different behavior in the UI. So that's a simple way of doing classification using a language model, but it's not the only way. In fact, there may be cases for doing it without a large language model. Imagine you've got some kind of high performance workflow system and you want to use AI to classify what's going on to trigger different behaviors, but you need it to be really fast and cheap and you don't want to call to an external large language model service? Well, it turns out you can do it with a small language model as well. And I'm going to show you an example of doing that. And surprisingly, I'm not actually even going to do this with .NET. I'm going to do it with Python. And the main reason to do that is not because you need to use Python. You can, in fact, do this with .NET perfectly well, but to show you more about the experience of using Aspire to orchestrate across a multi-technology system. And in fact, a lot of people who do AI development will say, hey, you know what? Some AI developers like to do different bits of stuff in Python. And the point we're trying to make here is, great. Just because you use Aspire doesn't mean you can't use other technologies too. You can, of course, bring in a bit of Python if you want to do a bit of AI with that as well. So what I've got here is a project in my Visual Studio solution called Python Inference, and I've got a bit of Python code in there. Inside there, I've got something that starts up a fast API server. So that's a bit like minimal API, but for Python. And I've plugged in a couple of endpoints, one classifier and one embedder. And I'm going to use this classifier. This actually uses a library from Hugging Face, which is a website where you can get thousands and thousands of open source models. And it's going to use this small language model called MiniLM2, which can do zero-shot classification. And we can just run that locally on this machine quite cheaply and fast without needing any external service. And this takes in some text and a set of candidate labels and decides which label is most applicable to the text. So to give you a practical example of that, let's say that my text is, this is a Python API, and the candidate labels are animals, programming, or music. If I do that, you'll see it classifies it instantly as programming. Whereas if I change it to, this is a Python, then it will classify that as animals. Or if I say, this is a song about Pythons, then it classifies that as music. And it doesn't need an external large language model to do that. And Aspire is perfectly able of starting up Python projects, just like Maddie and Glenn were showing you in the previous talk. And that's what I've done in this case. So now if I go into, let's say, the customer web UI, and I file a support request, we'll see how it gets classified automatically. So let's say I've got a support request for my foldy seat. And that's using semantic search, by the way, so I don't have to spell it properly. Can I fold this into a perfect cube? That's the sort of sensible support request that I think we can expect to get. So that is going to now go through that Python Hugging Face classifier, and you'll see it's been classified automatically as a question. Whereas if I do another support request and I say something like, I need to return stuff like that, and I submit that, then we come back over here and we see what we've got now. You can see that that one has been classified as returns. So this is another way we can do classification without a large language model that we can use to trigger different workflows. All right, so that's classification. Last thing we're going to talk about now is evaluation. And this is really where we become proper professionals. And we don't just take a guess about whether something works and just throw it into production. We're actually going to find out what the quality of our system is and have a systematic way of improving it over time by changing the prompts and the models or other things. And we can quantify how much we make things better. So how are we going to do that? Well, let's say we want to evaluate our AI assistant here. We want to evaluate the quality of the answers and the relevance of the answers that it gives. The way this is normally done is by having a set of test data. Okay, so all the test data that you've seen in this application so far has been generated using AI. I've got a project here called Data Generator that generates all that, and that generates the categories, products, customers. It generates the product manuals. It generates all the support threads, things like that. Just following a pattern that you can use for generating any sort of test data. But more interestingly, it generates a set of evaluation questions, which is a list of hundreds or thousands of different questions about the products. For example, product 35, what's included? And the answer is all that stuff. Or product 99, what kind of torque force does it work with? 15 Newton meters. And we can consider these facts to be the ground truth, because these facts didn't come out of the product manuals. These are the facts we generate first, and then we feed them into the product manuals. So we can consider them to be the ground truth. And now we can use this to evaluate our system. What we're going to do here is I'm going to start this up, the entire end-to-end system in the background in this terminal over here. And then I'm going to go into, actually, you know what, before I do that, let's just make a change to our system. So let's just kill all that. I want to show you what difference it makes to change your prompt in different ways. So I'm going to go into my assistant API here, and I'm going to start by doing a rather dramatic and, in fact, absurd thing, which is I'm going to remove some critical information. I've removed the product ID from the set of information that we're feeding into our assistant. And we're going to evaluate the quality of the system in this condition. And then we can try it with the product ID and see if we can observe an actual difference to the quality. So that's quite a dramatic and artificial thing to do. Right, so let's start up our evaluator project right now. You can imagine, if you like, that we've got a really beautiful UI for this, but you will have to use your imagination because we actually don't. All we've got is a console project right now, but just pretend that it was looking great, all right? I'm going to start this up. Okay, and what that's going to do is it's going to loop over all those eval questions and it's going to send them to the backend system. And this is a true end-to-end evaluation. It's not just evaluating the prompt or the model or the vector database or the chunking or anything else like that. It's evaluating the entire thing working together and generating a quality score by asking these questions and comparing the answers to what we consider the ground truth and assessing them for both relevance and accuracy. And over time, it builds up an average score. So you can see initially, we've got this average of about 0.381, which is measured from 0 to 1. That's quite a low score. It'll fluctuate a little bit, but eventually stabilize. And I happen to know from experience that it'll stabilize at about 0.4 or just under 0.4 eventually in this particular condition. But of course, it's kind of ridiculous because we're asking it to answer questions about products without even telling it what the ID of the products are. So it can't really search the manuals properly, which is why it's not working very well. And it's only getting scores of about 0.4. So what I'm going to do now is I'm going to give it the information back about what the product IDs are and start the thing up again. And then I'm going to run the evaluation loop one more time, and we'll see whether or not we get better scores this time than we did before. So let's start that up again. And remember, we were getting scores of about 0.38 or 0.4 or something before. Is that started? Yes, it is. All right. And it's now asking the questions again, but this time we've improved the prompt, hopefully. And we'll see what kind of scores we get coming out of it this time. Well, we're getting, in fact, we initially get a perfect score of 1. All the answers initially are absolutely ideal. That's a little surprising. Eventually, it will stabilize as an average that's a bit lower than that. You can see we're getting 0.75 or so. And again, I know from experience that eventually this average will stabilize with this particular prompt at about 0.78 or 0.8 or something like that. So clearly it's a big improvement. But also it's a very artificial thing that I did by removing critical information, just to show you a big change to the score. Now, for a slightly more realistic example, earlier on when I was building this sample in the beginning, I noticed that the assistant was hallucinating quite a lot. So I would ask it a question, and instead of searching the product manual, it just made up an answer based on nothing, and which wasn't very good. And it was scoring about 0.61 at that time. And I could see it wasn't searching the manual as much as it should. So I changed the prompt by adding this phrase: if this is a question about the product, I really, really want you to search the manual. That is important. And just by adding that one sentence, that caused the score to go up to 0.77, which is clearly a big improvement. But it also caused the time to go up from 2 seconds to 2.6 seconds, which makes sense because we spend more time searching and doing follow-ups with the language model based on the search results. So having this sort of system allows you, the developer, to make trade-offs, to assess the quality of different changes to your prompt or changes to the models or changes to other things, and see what impact that has on scores, what impact it has on time, token usage, cost, and all that sort of thing, and allows you to systematically improve your system over time. Aspire helps a lot with that. Aspire is the way that we're able to write these little console applications that interact with our backend services without having to hard code all of the URLs or configuration into them. It can just start it up using Aspire. All right, so that's all I've got time for just now. In summary, I would say there's a lot of different ways you can add AI features to your app. Chat is one of them, but also you should think about things like semantic search, classification, summaries, other things like that, that you can use to upgrade your existing app without having to build entirely new UI, without having to reinvent everything from scratch. So look at ways that you can upgrade your existing application. I would also say it's worth investing in having an evaluation system from the start, because that gives you confidence to make changes and be quantitative about what the improvements are that you're making. And Aspire can help you out with both the evaluation system and also keeping track of what's going on in production with your telemetry and trace data. I would say as .NET developers, you've got some great stuff available to you. Aspire obviously helps with orchestrating multi-project and multi-technology solutions. And Semantic Kernel helps a lot by giving you abstractions that work with these back-end AI services like language models or vector stores, things like that, and gives you a consistent programming model for them. And finally, I would say it's still early days, really, for intelligent apps. It's all still emerging. We're working out the patterns and the technology as we go. Right now, it might be that 6 months from now, there's quite different technologies and quite different patterns. We're all working it out, and I hope that you will contribute to the community and give us your feedback about what works for you or what doesn't, so we can evolve over time. Finally, if you want the sample code that I showed you, you will have to wait slightly longer because we're still going through a review process at the moment, but hopefully in the next few weeks that will become public. I've given you the URL here so that if you're watching the recording in 2 or 3 weeks, hopefully you can just go there and you'll find it. If you go right now, you're going to find a 404, but you know where it's going to be in a couple of weeks, hopefully. And that's it from me. We're out of time, so I hope that's useful, and I encourage you to enjoy some more Aspire talks for the rest of the day. Bye-bye.